In this problem, we are testing the claim that Brad Pitt has a higher percentage of votes than Jennifer Lawrence in this election for governor of California. So we've got a sample of 15 randomly chosen counties, and so you can say this is county, oops, there we go, county 1, county 2, county 3, however you want to designate those. So we have the different counties and then the percentage of votes in each county. And so we're looking to see, does Brad Pitt have a higher percentage on average than Jennifer Lawrence? So first thing I need to do is determine what type of test it is that we're talking about. So in order to determine that, I'm going to go through some questions. So first of all, is there one population or sample or set of data, or are there two? And in this case, we have two, because we have the Brad Pitt data, we have the Jennifer Lawrence data. Is this problem about a mean or a proportion? And when you have data, it's going to be about a mean. Because it's not really counts, and this one is a little sticky because it does talk about percentages and we're counting votes, but we're going to talk about the average here. So this is about a mean, and then so if we have two sets of data and it's about a mean, then my choices are that we have either independent data or matched pairs. And so let's take another look. So we have our data are paired up, right? So we can say that this is a matched pair situation. So matched pairs. And so what that tells me is that we are going to do a t-test with matched pairs. And we are going to enter the data, and for our data we're actually going to end up using list 3. So we'll see that in just a minute. So when we say type of test, I'm going to write t-test, and then specify that this is a matched pairs type problem. All right. So we've got our type of test, and next we're going to need our null and alternate hypotheses. So we're going to form the null and alternate hypotheses, and we know that this is a matched pair situation. Right? So my null hypothesis with matched pairs is always the same. It's going to be mu sub d equals 0, and mu sub d is the mean of the differences. So we've got the data paired, and we're going to say that the mean of the differences is equal to 0, that there's no difference between Brad Pitt and Jennifer Lawrence in terms of the percentage of the vote. That's the null hypothesis. And the alternate says that the average of the differences, now let's go back and take a look. What did they say? That Brad Pitt has a higher percentage. So this is a one-tailed test. We're not saying we just want to test to see if there is a difference. We're going to say Brad Pitt has higher average. And so I always go with a right tail test in these situations. You can go either with a right tail or a left tail, and that's part of what we're going to consider next. So I've got my null and alternate hypotheses, And now I've entered the data. So here's my data screen. I've entered Brad Pitt into list 1, Jennifer Lawrence into list 2, and now I need to form list 3, because when we have matched pairs, what we really do is we only test on the data in list 3. So we need to put data in there. So we're going to combine together lists 1 and 2 into list 3, and we do that by subtracting the lists. And here's where we get into our right tail test. I have to decide is sorry about that. There we go. Is list 3 going to equal L1 minus L2, or should it equal L2 minus L1? So how do I decide? What I'm going to look at is, if we're doing a right tail test, then I say, which is the larger? And in this case, we're saying Brad Pitt would have the larger. And I'm going to take the Pitt information minus the Lawrence information, because I go big minus small. And the reason for doing big minus small is because then we can say big minus small should turn out greater than 0. So what is it that we're kind of assuming in the problem is going to be the larger of the two? And I take the larger minus the smaller. Do I have to do that? No. I could subtract the other way, but then it would turn it into a left tail test instead of a right tail test. So how do you know which way it needs to be on your exam? And you can actually go either way, and you get the same result. So, or not the same result, but both results are legitimate. So, and I can grade according to that. So, in this case, I've decided to go with L1 minus L2. Make sure that you're in the very tippy top here, not where you're entering the data, not in the data area, where you're naming the list. You go up to the very top there, and you type in L1 minus L2 by hitting second and the number 1 minus second and the number 2. And once you hit enter, then you have, well, the whole list gets filled in there. All right, so now we're set with our data. We've got all that filled in, and now let's go back, start filling in our table here. So our null hypothesis, oops, darn, sorry about that. Our null hypothesis is mu sub d equals 0, and the alternate is mu sub d is greater than 0. Okay. And now we're ready to do our test. Okay, so we're conducting our test. So our input is data, because we have our data from our list. Mu 0 is 0. Our list is L3, and the frequency is 1. And we're doing a right tail test. And now I can either choose calculate or draw. And I'm going to give you both results on the next page. If you get an error when you hit draw, go back to the y equals screen, and up at the top it'll say plot 1, plot 2, and what you'll see in that case is that plot 1 will be shaded in, and you hit the up arrow, enter, and that'll turn that off, and then you won't get that error anymore. So, calculate or draw, and that's how the calculator is going to process the test. So let's take a look at the results. So here are my results of the calculate screen and the draw screen, so whichever one you choose. Personally, I like the draw screen because it gives what we're interested in here with the test statistic and the p-value, and it rounds the p-value to 4 places, which is very convenient, and you're less likely to see scientific notation here. So if the p-value is going to round to 0, it'll just say 0 instead of giving you some really long scientific notation, which is what can happen here, and it didn't happen in this particular case. So, let's take this information back to our chart. Now, the degrees of freedom is going to be the number of data values minus 1, and when we have matched pairs, that's simply the 15 pairs minus 1. So that's 14 for this particular problem. And our test statistic was 1.31, and our p-value, okay, sorry, I'm having a zooming issue here. Our p-value is 0.1057. Okay, so now we are going to compare this p-value to our significance level, and our significance level is 0.05 because it's at a 5% significance level. So which is greater, our p-value or alpha? And the p-value is greater. So what that tells me is that I should not reject the null hypothesis. What we're saying is that any difference that you see between our data, it's not significantly far away from 0. So our conclusion would be then, so I put the data do not indicate a significant difference in percentage of vote for Pitt and Lawrence. And that's probably not exactly what I wrote in the answer key, and I didn't get a chance to take a look. But you just need a statement something like this. You're not going to say that the percentages are the same. We're not indicating that. All we can say is that we're not seeing a significant difference based on the data in percentage of vote for Pitt and Lawrence. So it's just not far enough out there to say that it's a significant difference. And so that is our final answer.